Alright, in today's videos, I'm going to be explaining derivatives and what they are and how they work. So to explain what a derivative is, we have to first understand why we use them. So what we're doing is we are trying to find the slope of a certain point on a curve. So if you have a function, let's say it's y equals 2x, it looks like this. If I say, let's take a point here on the curve, and I ask you, what is the slope of the curve at this point? You would say, well, okay, I know that the slope is y equals mx plus b, and the slope is m, and here in the equation it's 2. Therefore, the slope is 2, and that would be correct. But now I say, let's take a point here on the curve, right? And I ask you the same question. What's the slope at this point? You would say, okay, again, y equals mx plus b, and we have y equals 2x. M is equal to 2. And you'd be correct. The slope is the same. So that seems pretty handy. Why do we need to have this whole complicated derivative calculus if the slope is the same at every point on the curve? And while that is true for some functions, if we have a function like, let's say, y equals x squared, now it gets a little more complicated. Now y equals x squared is, oh, that's a terrible drawing. It's going to look something like this. And you have your axis, hold on. Okay, that's a little weird. Hold on. There we go. That's better. Okay. It's gonna look something like this. This is y equals x squared. F of x equals x squared. And I ask you, okay, find the slope at this point. How are you gonna do that? Now, the slope at point A is gonna look a whole lot different than the slope at point B. You can visualize this by, actually I'll put the letters on this side because I have to do something in a sec. Here and here. Point A and point B. And we can visualize this by drawing a line tangent to these points. Tangent means it is just touching the point but nowhere else on the curve. So a line tangent to point A would look something like that. And a line tangent to point B would look something like that. You can tell that the slope of these two lines that are the tangential lines are very different from one another. The line tangent to point B is much steeper, right? Which means it has a higher slope there, higher m value. But how do we find that value? And if you guys know one thing about slope, it's probably rise over run. It's y2, not y squared, y2 minus y1 over x2, whoops, sorry about that, x2 minus x1. Okay, so how do we derive this? How do we use derivatives and, get this slope? Oops. So if we go ahead and look at point A for this example, let me just erase these lines. Okay. Let's say we had point A, and what is the x value of point A? Let's call that x. Or sorry, no. Sorry. Let's call that A. I know it's a little confusing. I'll remove this. Whoops, okay. If we want to find the slope, we have to use this formula. But if we wanted a second y value and a second x value, we'd have to take another point, right? And we could take point B, but that would find the slope of this. And we want the slope of point A. But remember, if we want the slope of one point, it doesn't make sense to take 2 points, right? So that's why we have to take a point so close to point A, it's practically 0 units away. But for the sake of this drawing, I'm going to place the unit here. But in practicality, this distance is 0, right? So again, we want to find the x value of this point. Let's call that b. I don't know, it's like confusing. Actually, I'm not going to call it b. Just know is the second point. And the x value of this point is going to be a plus h. And if you're asking yourself, what is h? H is a limit that tends to 0. And what that means is it is, in all practicality, it is 0. Because the distance between these 2 points are so small that the x values do not change, right? And now we need to find the y values. And if we have our function y equals x squared, well, the y value is just going to be, or not x, sorry, a squared, sorry, f of a squared, not a squared. And then we have f of a plus h squared right here. Oops. Wait. Hold on. Sorry. A plus h whole thing squared. Okay. So now you have your y values and you have your x values. How do we find slope? Y2 minus y1 divided by x2 minus x1. So let's take our first value, which is going to be a plus h squared, and we have to subtract the y1 value, which is just a squared. And this is all divided by x2 minus x1, so that would be a plus h minus a. Let's simplify this first. We can simplify the denominator pretty easily by just removing that h. A plus h minus a is just equal to h, right? And so we're left with this. But how does that help us? Now, we have to simplify again. Simplify the numerator this time. And if you guys should know, this is really handy, especially in calculus or in math in general. When you have a term like a plus b whole thing squared, like this is equal to a squared plus 2ab plus b squared. So this is just this, right? Oops, that's a terrible arrow. So what's a squared? Well, a squared, right? We have a 2, and then a is a, and b is h. Then we have plus b squared. B is h, so h squared. There. Minus a squared over h. Now, let's go ahead and simplify a little bit more. And the way we are going to do that is, well, we have a squared minus a squared, so those can cancel out. And we're left with 2ah plus h squared over h. Now we can factor out an h. And, well, first let's remember, h tends to 0. So if we were to just leave it at here and say, okay, h practically is equal to 0, anything divided by 0 doesn't work, it's undefined, right? So this would not work. So we first have to factor out an h in the numerator. And that becomes 2a plus h in the numerator over h. And we can cross those out, and we're left with 2a plus h. A is just x. I used a because that's how most of the time it is written in the textbook. And so, again, h tends to 0, so we're left with 2a, and the derivative of f of x equals x squared. Actually, don't write equal to sign because that's not equal. Is, sure, I'll make an x. Is 2x. So there you go. That's how you do derivatives. As the function gets more complicated, it doesn't get really much more complicated. And there is a handy trick where you don't have to go through this whole process, simplifying, factoring. to get this number, to get this 2x, but I'm just showing this to you so that you understand how it works, because if you understand how it works, it makes it a whole heck of a lot easier when you get to more complicated expressions. And so, yeah, that is derivatives for you. I will be exploring them a little bit more in my next video, so stay tuned for that.